All right. Hello to all of you. I'm glad to see you. And now we'll have a quick talk about Kotlin. We'll analyze it and compare with similar Java code. So we'll look into Kotlin in decompiled form. So a few words about me. I'm Klymenko Ruslan. I'm a software engineer at Zero Labs now. I'm passionate about Java Virtual Machine. Also, I'm a co-founder of Java user group in Ternopil city. If you don't know, it's in Ukraine. And I'm a founder of Dobry IT. It's a non-profit organization which helps people to learn internet technologies and Java as well. Few questions to you. So who knows about Kotlin? Oh, great. Almost everyone. And who have worked with Kotlin? The same people, less people, great. Who use Kotlin in production? Who use Kotlin in everyday practice? Only some of you. All right. To those who don't know what is it, it's a language. Basically, it was language only for Java Virtual Machine platform, but for now it's not true. It also can be compiled to JavaScript. It can be compiled to native code. So it's a multi-platform project right now. It's modern, yeah. So it started in the beginning of 10th of this century. So it's more modern than Java, for example, than Scala. It can work with JVM, as I have mentioned earlier. And also it's statically typed with comparison, for example, with Groovy. Yeah, in Kotlin you have pretty the same feature, but it's statically typed. So it may be better for some cases. Why we are interested in Kotlin? Because we have, for example, such charts. Here we have a TOP index. If you know what it means, it's like statistics about usage of different programming languages. So Kotlin on the 17th position right now, and the trend is that it becomes more and more popular. So it's a rising star of programming languages. And according to survey of Rebel Labs, we can see that Kotlin is the most interesting language from developer's perspective. So if developer can choose language, he will definitely choose Kotlin. One more thing about Kotlin, yeah, as we have mentioned, it works with Java Virtual Machine. So it's comparable with Java and any other code which can be interpreted and compiled by a Java Virtual Machine. So because of this, we have full interoperability between Java and between Kotlin. To those who don't know what is bytecode, it's a result of compilation of Java code or Kotlin code or Scala code. So it's intermediate representation which can be executed on virtual machine, Java Virtual Machine. And we have a lot of bytecodes. You can see them on this slide. It's not so trivial to understand them because we have just hexadecimal symbols here. To more readability, we have this concept of mnemonics. So mnemonics are some mappings between bytecodes and their actual meaning. Why I'm speaking about all of those details, because in our presentation we are going to compile Kotlin code, to compile it to form of this bytecode, which we look at. And after this, we will going to decompile it. It's another process which just gets machine code and converts it to high-level language. So the idea is to compile Kotlin code and decompile it to Java. So in this case, we will see the difference between Java and Kotlin, yeah, and how Kotlin code will look in Java. Here is just my explanation. Let's skip it because we have limited amount of time. So the first thing that we have here is hello world method in Kotlin. So it's simple, and as you can mention, actually, what we have here, just method without any class declaration. So how it's possible? How it works? Actually, when you compile simple hello world, which is declared on a class scope, but not in on a file scope, but not in a class, you will see something like this. So Kotlin just creates a wrapper class for your file, and class name will correspond to file name plus KT extension in the end. So my file was named test1, and we can see as a result test1 KT class. Main method pretty the same that we have in pure Java. But also what's interesting, we have here metadata annotation. Who knows what is metadata? Why it's used here? In 2 words, it contains information for runtime which cannot be represented in pure JVM instructions. Yeah, we need additional place for, because of these purposes we use annotations in general. And in Kotlin, the same story. So in Kotlin just gives additional capabilities to Java users, but Java virtual machine cannot just write out of the box, gives all of placeholders for this additional information. Because of this, in Kotlin we have metadata annotation, which contains things that critical to Kotlin, but cannot be represented in pure Java. And one more thing, we have some heuristics here. So we have a check. Actually, it's a check for nullability. As you know, Kotlin is a language which promises you to just remove all of the null pointers from your program. And actually, how it's implemented, we have 2 categories of types in Kotlin. It's nullable types and not nullable types. Yeah, if you're a newbie in Kotlin, you may not know it, but actually how it looks in Java, you can see. So each time when we work with not nullable type, Kotlin compiler will insert additional instruction to check actual value of your variable. And if it's null, you will see exception right at the beginning of your application, but not in the middle, not in the end. So because of this, we have a more strict type system in Kotlin. One more interesting thing, which is not represented in Java, it's extension methods. It allows you to define methods on types, and you can define this method not in the scope of class itself. You can define it outside of a class. You can define it even for final types, which is cool, because in Java it's not possible to do it. Here it is how it looks. We just define a method on a string type, which is named isTest, and it just checks that this object is equals to test. How it looks in Java? Let's look into it. So here is what we have. We have just a static method, yeah, which receives string, and after this we just execute all of the logic on this string. So we just passed the object with which we are working into the static method. Here is the main idea. But from the Kotlin perspective, you will work with it like with any other method. So you will just call some method on a string, and it will look like it's defined on a string. So it's cool. In Java, you cannot do it with Kotlin code. Yeah, it's because you saw bytecode, you saw the compiled form. It's because we just have pure static method. Let's go next. So we can define classes in Kotlin in a very fast and interesting way. So here is the simplest declaration. What we have here, we have a class with only one field, which is test of type string, and it's a val value. Here is the difference between val and var. If you know, val is final, var can be changed. So this simple declaration of a class will give you something like this in Java equivalent. So you will have a constructor which receives a string. You will have a field of type string, as we agreed, yeah, and you will also have a getter for this field. Actually, if you will just change your val to var, you will see setter method also. Next thing that is not represented in Java is default arguments. So you can do something like this. So the idea is that if you don't pass test string to your constructor, the default value will be used. How it's implemented? Actually, here is what we have in Java equivalent. We will have a simple constructor which receives string. Yeah, it will work the same way as in Java, but also we will have default constructor which calls another one, synthetic method, synthetic constructor, as you can see. And the idea is to pass bit mask which will compare which arguments of constructor is not passed from the client, and if the bit will be turned, yeah, in this case we will use default value. Data classes, something like case classes in Scala, so they just help you to create POJO types in a fast way. You just add data keyword before class declaration, and you will have all of the stuff. You will have all of your fields. You will have getters, setters. In case of if you use var, not val, you will have constructor with parameters. You will have 3 basic methods of every Java programmer is toString, hashcode, equals. And also, what is interesting, you will have something that have no equivalent in Java. You have component methods. As you can see, we have component 1 and component 2 here. Why 2? Because we have 2 fields. So for each field, we will have component method. I will explain what it means on the next slide. From this slide, also, you need to notice that we have copy method here. So it's just shallow copy your object. Well, why and how we can use these component methods? They are used for destructurization of objects, if you know what it means. So the idea is to get complex type and destructurize it to simple variables, just extracts all of the fields. And from the Kotlin, you can use something like this. If you will have type test6 with 3 fields, as a result, you can get access to all of them just in one instruction. Yeah, from Java perspective, you can see it on the right side. It's not possible to do such trick. You can just call this component 1, component 2, and component 3 methods. They are not so cool. But from Kotlin, you can do it. All right, primitives. So the simplest program just returns fixed integer literal, which is 1. We can do it in Kotlin as listed on the left, and in Java it will be something like this on the right. One more thing, when you work with Kotlin, you can use Kotlin primitive types. But the interesting thing here, you can see that if we define int, yeah, in the Java code, it will be represented also as primitive, but not as a wrapper on the primitive. So it's cool. But one more cool thing, that you even can use methods which are general to primitives on those types. So think about it. In Java, you will have primitives, but you can work with them as an objects in Java. So it's cool. You can just call toString, compare to, or hash code on actually int of Java int. So here's what we have in the result. Type hierarchy in 2 words. I said about it. So we have nullable and not nullable types. Yeah, not nullable type is a subtype of nullable type. At the beginning of hierarchy, we have any type, which is equals to Java object with some nuances. We have additional operators to work with nullable types. For example, else operator, which will check if we have actually value inside our variable, and if not, if it's null, we return the value which is listed right after expression. One more thing to notice. If you, by default, all of the types in Kotlin are not nullable. If you want to do them nullable, you need to add additional symbol, which is question mark. And it's a hint for a compiler that this type can be null. Here is the same thing in Java code. All right, let's skip some details. Good thing about Kotlin, yeah, actually, if you want to do some casts or compare types, you can use is and as keywords. Is just like instance of in Java, and as casts your given variable to given type. But interesting thing is that when you use is, inside the scope which was checked by this is, you can use all of the methods defined on your type which you checked, yeah, on your variable. So for example, we have actual any type we check if it's string, and if it's actually string, we will go to this block, and after this we can use all of the methods defined in string. So it's cool. In Java, it will look in such way. You can do casts each time when you want to do specific operation. When actually interesting thing, you can check not only values but types also. If you work it with Scala, you will find nothing new here. All right. So actually, the sad thing that we have no more time, but I'm open to questions. If you have questions, you can ask me. And also, I believe I will share the presentation, so you can just go through it if you're interested after on your free time. So actually, the conclusion is Kotlin is really nice and future-rich language, which is modern and which is maybe used as an alternative to Java. And I work with it personally about 1.5 years, and I'm happy. And when I return to Java, it seems much slower, and I need to write more code to do the same things. So actually, thanks to all of you. That's it.
Thank you.
Any questions, please?
Maybe just go through the negatives of
Yes. In 2 words. Actually, you can learn new language. It's simple, but you need to do it. The compilation speed is slower than comparing to Java, but not so slow as Scala, for example. So it's in the middle. If you write something like microservices, which are not too big, it's not a problem to you. But if you have a huge monolith, it may be a disadvantage. And actually, the community of people who uses Kotlin is smaller than Java. I think it's understandable. But the tendency that Kotlin rises. So I think in a few years it may be comparable to Java in this sense.